fun stuff that we know. But, you know, it's important in terms of probably someone might forget little things, and this will aid you. And today we are looking at measurements, right? Even though we might say mathematics is really come down to measurement and the measuring tape. So we don't really want to stress out too much and spend too much time. Most of you all is fabricators. I guess partly all is fabricators or fitters. So I mean, you know the measuring tape to that extent. But we'll just do a little review because the practical calls for that, and the instructor say make sure they can calculate and stuff like that. So we just touch on a little review based on that. Right? So we're looking at trade maths. And trade maths is what we call applied maths in the industry. Or if you have to do any trade, any tertiary education trade, right? Whether it's certificate or diploma, right? Or technician level, it still go by applied maths or applied calculation, right? So introduction to it, our author here is saying, it says basic math skills such as addition, subtraction, multiplication, and division are used every day in the construction industry. Everybody in?
Yes, sir.
All right. These skills are the foundation for more complex math skills that are used in construction, such as working with fraction, percentage, decimal, and the metric system. Maths are used for tasks as simple as counting nails and as complex as calculating the dimension of a building. All trade in the construction industry use maths. For example, an electrician uses maths to determine how much wire they need. Pipe fitters use maths to accurately measure piping and fittings. And technicians use maths to install and operate testing equipment. Maths are priority. A good understanding of maths also helps ensure safety on the site. All you believe that? A good understanding of maths help promote safety on a job site. Everybody agree that statement, or are you in see eye to eye with it?
Yeah, we agree with that.
Yeah, that makes sense.
All right. The same measurement and calculation must be accurate to avoid material and equipment failure. Example, like if you're doing rigging, right? You know you have to calculate the weight of the material, right? While I was away, before we make any lift, the fabricator have to calculate estimate weight of the piping. So you go a chart with, say like if it's a 150-pound flange, how much it go weigh. If it's a 4-inch pipe, depending on what schedule, you'll know how much it will weigh. So you make an estimate, a rough estimate, before the crane man even attempt to pick it up, right? So measurement and calculation must be accurate to avoid material and equipment failure, both of which can result in accident and injury. Take the time to do the maths required for your job carefully and correctly. So today we'll just take a little time, roughly about an hour, and we'll just review some of the things that we learned probably before, or probably sometime earlier this year, right? But it's things we know from since we're small, right? And well, we didn't go into the addition and the subtraction part, but we could start off directly with the fraction. And when we think about fraction, we think about the measuring tape and the imperial system, right? A fraction is said to be part of a whole. So example here, you have, let me picture the measuring tape. If the measuring tape measuring in 8, right? That means that 1 inch will comprise of 8 parts, right? So if you say we get 1/8, 1/8 simply means we take one part out of that 8, right? So we will go back to the reading here. Numerator and denominator. When writing a fraction, the number above the line is called the numerator. We know that from since the primary school, right? So the number above the line is the numerator. What the numerator does, it shows how much equal parts are taken. So if we look back at the example, one part is taken out of the 8. Right? The number below the line shows how many equal parts there are. It is called the denominator. So how much we measure in here, what we measure in here is we measure in 8. Right? Now, numerator above, denominator below. Now, when we look at this, we look at the measure. Just picture everything as the measuring tape. And all these circles saying the same thing. All of them represent half. But you know, on the measuring tape, you could say you could have 1.5, right? If we're dealing with quarters, 2/4, right? Because we check it in quarters, but 2/4 is really half still, right? It's 2 parts out of 4, so it's half. 4 out of 8 is still half, because it's 4 parts taken out of 8, right? And if we're using 16 and we have 8/16, it's still equivalent to half. Nobody wouldn't go in our stores and ask for a 8/16 spanner or a 4/8 spanner, a 2/4 spanner. You will say you want a 1/2 inch spanner, right? It's only realistic, right? But within then, you could ask for an 1 and 3/16 spanner. You could ask for 1 and 1/8 spanner. You could ask for 1 and 3/4 spanner or 1 and 1/4 spanner, right? So we use it based on, we use the different terms based on what we asking for in this case. But within measurement and within the measuring tape, the smaller increments on the measuring tape could either be half, quarters, 8, 16, 30 seconds. Right? Everybody with me? A little feedback.
Yes, sir.
Right.
Yeah.
Okay. So once we're talking about fractions, we have to talk about the type of fraction. Right? And if we look, it really comes down to 3 types of fractions. Right? We have proper fraction. They say if the top number of a fraction is less than the bottom number of the fraction, it is called a proper fraction. In this case here, they use 2/3 and 5/8. But you know, if we're dealing with the measuring tape, we're going to have like 2/3. We didn't come across 2/3. We're going to have like 8. So it could be like 1/16, 1/8, a half, a quarter. All of these is proper fraction. 3/4 is proper fraction, right? Once the top number smaller than the bottom number is a proper fraction, right? Improper fraction. If the top number of the fraction is greater than the bottom number of the fraction, it is called an improper fraction. So once we have a fraction with the top number being bigger than the bottom number, let me give you an example now. You have 18/16, right? 18/16, right? That's an improper fraction, right? You have 5/4, improper fraction. I'm just pointing back to the measuring tape direct, right? And once we have that now, once we have the improper fraction now, we will turn this into what we'll call here a mixed number, right? So when the improper fraction is written as a whole number and a proper fraction, they are called a mixed number, right? So once it's written as a whole number, right, and a proper fraction, it is called a mixed number, right? So before we go on, right? Everybody with me? Yeah.
No. Yeah.
All right. Everybody with me. Everybody, if you're close. Now, today exercise, really and truly. If you have a calculator, you should have a calculator, pen or pencil, and a sheet of paper, right? So if you don't have it, I'm giving you 2 minutes to get a calculator close by, a pencil, a pen, and a piece of paper, right? Now, all you have to listen to me closely, because as I say, this blackboard is really working good. I have a mouse, and the Word document I was looking for, I couldn't get to upload it. Matter of fact, I'm not getting the flash drive. I have it on, right? So what will happen? I'm going to listen closely, and I'll call some improper fraction, right? And then after, I'll just call about 3 improper fractions, and you'll just put it into a mixed number for me. Right? Everybody understand? Somebody say yeah, nah. Everybody get cold, boy.
Yeah.
Yes.
Crystal, you there? All right. Let's see if I can type here. Keys and ages. So everybody the first one, right? Everybody had a pen and pencil. So the first one we're looking at we will start off at 6 over 4, right? 6 over 4. Right, that's the first one. The second one, nine over 8. Right? The third one, 20 over 16. Right? And all I have the 3, only want me to repeat them. Don't give the answer yet. Right? Everybody write down the 3 fraction I call 3 improper fraction I call. The first one was 6 over 4. The second one, 9 over 8. The third one, 20 over 16. Now this is just to see if you understand what we're doing with the measuring tape. Right? We're taking this improper fraction, right? And we're putting it into a mixed number. So at the end of the day, we'll have a whole number and the remainder over the denominator, right? Oh, yeah, give 2 more minutes. Everybody finished? Class leave me. Naomi?
Yeah.
Who answer here? Frank?
Yeah, man. Yeah, any loud and clear. Ready?
So everybody finished, right?
Yeah.
Alright. So The first one, anybody at all. I want to call nobody. I just want anybody at all. Say your name and just give me the answer for the first one.
Yeah, nobody can. 1 and 2 over 4.
1 and 2 over 4. 1 and 2 over 4. Who give me the answer, Tiba?
Me and Nona, somebody.
All right, 1 and 2 over 4. Everybody agree on that?
Yeah.
Mackenzie, agree with that?
Yeah.
Well, I pray strong. 1.5.
Yeah, well, the same thing. Right? Yeah, the same thing. Now, I know somebody that say, well, sir, 1.5. So whether I have 1 and 2 over 4 or 1.5, it comes back to the same thing. Right? So that's absolutely right. Right? Somebody give me the second one. A girl. One of the girls, give me the second one. You're shy, boy. All right, a fella. Anybody?
1 and 1 8.
1 and 1 8. That's absolutely right. 1 and 1 over 8. Right? And the last one.
1 and 4 16.
1 and 4 16. Break it down further.
1 and 1 third.
Now, Mackenzie, talk to me.
1 and a quarter, sorry.
1 and a quarter.
Man.
1 and a quarter.
Sorry.
Yeah, that's absolutely right. So we understand what we're doing when we talk about the measuring tape. We understand what we're looking for, right? Now we'll just do we touching everything. We don't have to really touch much on the multiplication. We not to touch the multiplication and the division when you're talking about fraction more or less, right? Now it's there and we can mention it, but the key thing about fraction is knowing how to add fraction, add and take away. Because remember, if we're working on that cut length, right? If we're working on that cut length, we have to start off with our original length, right? And we have to minus, if we have the fittings, we minus the fittings, right? So basically, the main thing within the realms of calculation, within the realms of fabricating and taking measurements, is really adding and subtracting the fraction. And that way that's come down to the addition and the subtraction of fraction, right? Let me see if my mouse kind of stick there. Let me move on, right? So once we started talking about fraction, we're talking about multiples now, right? They say a multiple is a number into which another number can go an exact number of times. So if we say 2, 2 could go into 2, right? 2 could go into 4, it could go into 6, 8, 10, right? If you're looking at 10, 10 could go into 10, it could go into 20, 30, 40, 50, 60, and so on. Why multiples are important? Once you start to do the addition or the subtraction or fraction, I'm getting the to write on these things. Right. My presentation kind of changed a little. Let's talk to me.
Yeah.
Yeah, I downsize it because I want to be able to type on it now. Right? If I leave it in the slideshow, I can't, it's not allowing me to type in the slideshow. Right? So, talking about the multiples, and we're saying here, once you start to talk about the addition and subtraction of fraction, right? You have to come up, first step you're doing is, whatever you're adding, you bring it to the lowest common multiple of the fraction, right? So if we look at the example here, in the addition example, we have 5/8 and we add in a half, right? 5/8 plus a half. So in this case, the lowest common multiple is 8. When you're looking at the measuring tape ranging from half to quarters to 8 to 16 to 30 seconds. You could go up to 64 now, right? And that is it breaking down. So even though if you're counting from a regular counting from 1 to 8, 8 seems like the bigger number. When we're dealing with the measuring tape, right? 8 is really the lower multiple, right? So we're looking at this fraction here, 5/8 plus a half. And we say 8 is the lowest common multiple. Now, remember, if for those who was in the class, remember I show you have two ways you could do this. You could add, right? If you go back to the primary school way, the traditional way which we learn, we say 8 is the lowest common multiple. We draw a line, we put the 8 below. Then you're saying 8 divided by 8 is 1. 1 multiplied by 5 is 5. Put it above the line. You're saying 8 divided by 2 is 4. 4 multiplied by 1 is 4. And you add both of them. The denominator staying the same. You're just adding the top, the numerator. Right? So in this case, when you add them, you get 9/8. Right? But 9/8 is what we call an improper fraction. So with this improper fraction, now we have to bring it to a mixed number. And when we convert that to a mixed number, we get 1 and 1/8. Right? Everybody see the steps? The steps simple enough?
Yes, sir.
Yeah. All right. Now, that's all right. Then I'll 1 minute. Right. So, seeing that we know this, right? You have your pad and your pencil, right? You will just write a couple of common ones, right? And we will just do about 2. So we're gonna add 7/8 plus 3/4. Right? That's the first one. 7/8 plus 3/4. All I have that? 7/8 plus 3/4. Right? That's the first one we'll be doing. Right? The next one we'll be adding 1 5/8 plus 2 and 3/16. Right? 1 5/8 plus 2 and 3/16. Right? You'll take a little 6 minutes and do it right now, right? So the first one is 7/8 or 7/8 plus 3/4. And the second one is 1 5/8 plus 2 and 3/16. Everybody done? Everybody done? Yeah, no answer. Only with me? On my call for? Naomi?
Nah, you might good, you might good.
Oh,
You taking me time.
okay, all right, all right.
Mr. Kada,
Yeah, all are finished.
what's the first one again there?
7 over 8 plus 3 over 4.
And the second one?
1 and 5 over 8 plus 2 and 3 over 16.
Alright, good. Quarter, 1/8, quarter, 3/8, half, 5/8, 5/8, 3/4, 7/8. So that's 3.
Already.
Yeah. Yeah.
Who else saying yes?
Yeah. Andreas. Yeah.
Andreas, right.
Ready, the first one.
No, wait.
Oh, waiting. All right.
Wait, I need you say yes. I need one person to say yes so far. If I have about 4 people say yes, I'll say yes.
Yeah.
Go ahead.
Good.
All right. So ready?
Yeah.
Okay. So Andreas, give me the first answer. Let me hear your first answer.
Yeah, the answer is 1 and 5/8.
158.
1 and 5/8.
Yeah.
Everybody agree with that?
Yeah, Roger. 158.
All right. 1 and 5/8. Everybody agree. Right. Anybody at all disagree? Say no with us. All right. Give me the second one. Somebody else give me the second one.
3.5.
Everybody agree with that?
13 to 13, 1. 13 into. Oh, yeah.
3.5 or 4.5.
What do we get at?
All right. What do you get? Somebody else?
3 and 13, 16.
Who said that?
Sukram.
Nah.
Sukram. Mackenzie, what are you saying?
Yeah, the same thing Andreas said.
What is that?
3 and 13, 16.
3 and 13, 16. Frank. Let me hear you.
Yeah, me come this thing.
Frank, you know with me today.
That's why I asking what is the question and nobody answering me.
Oh, we hear you.
You mind and child and thing.
All right. Alright, the answer is 3 and 13, 16. Right? 3 and 13, 16. Because when you break it down, 16 divided by 8 is 2. Multiply by 5, you get 10. Right? 16 divided by 16 is 1. Multiply by 3, you get 3. You add your whole numbers one side. 2 and 1 is 3. Then you add in your 10 plus 3, you get 13. And the denominator staying the same, 16. So everybody more or less on the correct page. Alright? So let me look at that addition. So we'll pass on. Alright. We're looking at subtraction now. Right? And they give you the steps. First thing, as with all fraction, you find the lowest common multiple the fraction. We have here 5/8 minus a half. The lowest is 8, right? So you put the 8. And then you say 8 into 8, 1 multiplied by 5 is 5. 8 divided by 2 is 4, multiplied by 1 is 4, and you minus them, right? Denominator stay the same, you minus the numerator, and then which is 5 minus 4, you get 1 over 8, right? You saw I have this circle drawn this side here, but I can't really do nothing with my circle, right? It doesn't allow me to really write and stuff. So, right, but everybody get it picture, right? So we will try 2 with this, we will try subtracting 2 of them, right? So where we're looking at 15 over number 1 for the subtraction is 15 over 16 minus 3 over 4. Frank, you get that? 15 over 16 minus 3 over 4. Right?
So repeat it over, please.
15 over 16 minus 3 over 4. And the second one is 6¼ inches, 6 and 1 over 4 minus 1 and 1 over 2. So 6¼ minus 1½.
What's the second question again, Caro?
6¼ minus 1½.
All right, thanks.
Right, everybody finished?
Yeah.
Who said that? Supram?
Everybody finished.
Everybody finished. I like that, man. So, I guess that T-Bar will say everybody finished, right? So, T-Bar, give me the answer for the first one.
First one, I get 2/4.
2/4. Do you agree with that?
So I get 1/8.
A man get 1/8. What did I know for the first one?
5/16 minus 3/4.
No. It's 15.
It wasn't 15/16. I get 3/16.
Yeah,
Yeah,
15 over 16.
Minus 3/4.
I get 3/16.
3/16 is absolutely right.
15/16.
Yeah. Second. Minus 3/4. Right? Andreas, what you get?
Same thing.
Wait, I don't know why the same thing.
Which one that was?
I get 3 answers, you know. The first one, what you get?
Where was the first one?
15/16 minus 3/4.
Minus 3/4, which is also equal to 15/16 minus 12/16.
That's right.
Right, so that is 3/16.
3/16.
Yeah.
Right? Andreas, that's you talking and giving me the calculation there?
Yeah, I mean.
Right. Right, you see, the more you do it, probably minus it. Now to turn 3/4 into 16, that means you're multiplying the top and the bottom by 4. Right?
Yeah.
So if you multiply the top by 4, 4 3s are 12, and if you multiply the bottom by 4, 4 4s are 16. So you're going to know 3/4 is equal to 12/16. So when you're minusing it now, you just say 15 minus 12, you get 3. So your answer is 3/16. That's how you work it out quick, right? But if you can't work it out quick, you know you write it down and you go the long way, right? And what about for number 2? I want to hear Andreas. I want to hear somebody else. Where's Smurf?
Yeah.
5 1/4. 5
You're wrong.
1/2. I know 5 1/2, 5 1/4.
5 1/4.
Minus 5 1/4.
Mackenzie, give me the answer.
Hello. Negative 5 1/4.
Yeah,
Mackenzie.
negative 5 1/4.
Yeah.
What answer you get?
I feel them and I'm thinking of the fractions, boy.
Yeah.
Something going wrong with the conversion. I got 4 3/4.
All right, Andreas, what do you get?
I get negative 5 1/4.
5 1/4.
Nah.
Right, negative 5 1/4. No, 5 and negative 1/4.
Alright. What's
Andreas.
something?
Yeah.
The original thing was 6 1/4 minus 1 1/2, right?
That's right.
So if you're converting everything to quarters, the 6 1/4 when you convert it, you're multiplying the 6 by the 4, you'll get 25. 6 by 4, 24, sorry. And then you add it to the 1 on top, you get 25/4. Right?
Who talking there?
1
Mackenzie?
1/2. Yeah. Well, I'm breaking it down for them now.
Yeah.
1 1/2, right? 1 by 2 is 2, and you add it to the one on top, you get 3 over 2. But because you want to convert it to quarters, you multiply the 3 over 2 by 2 to get it to 4. So 2 by 2 is 4, and 3 by 2 is 6. So you get 6 over 4. So you end up with 25 over 4 minus 6 over 4. Right? 25 minus 6 will give you 19, so you end up with 19 over 4. And when you do your division, 4 fours is 16, and you have 3 remain to make up the 19. So that you get the 4 and the 3/4. I know it's
Alright.
it's ideal because you know blackboard and thing to show now, but
Yeah. Yeah, but you said right. You said right, eh? But right. So the answer is 4 3/4. Now Mackenzie, I meet students in the past doing it that way too.
Oh, the answer is 4 3/4.
All right. Now listen, man. Listen, man. I can't write to show all here, right? But here how idols work it. How Mackenzie work it absolutely right, right? But here how idols work it now. You listening, Mackenzie? Remember we have 6 and a half, right?
Oh.
And we minus 1 and a half, right? Now, if you look at it, quarter is less than a half, right?
right.
So because quarter is less than a half, you're borrowing 1 from the 6. So when you borrow 1 from the 6, you're paying 5. And you're adding to that quarter, you're adding 4 over 4. Because there's a whole you borrow. So you're ending up here with 5 and 5 over 4 minus 1 and a half. And then you start to do you start a minus from the, right? Quarters is the lowest. So 4 into 4 is 1, multiplied by 5 is 5, minus 4 divided by 2 is 2, multiplied by what is 2. So you're ending up here now with the whole number is 5 minus the next whole number, which is 1. So you're ending up with 4, and 5 minus 2, you get 3 over 4. You understand it?
Right, yeah.
Mr. Kado,
Yeah, but you don't understand it.
Mr. Kado,
Yeah.
And the fraction is 6 1/4 minus 1 1/2.
That's right.
No, I do roll and thing.
No,
You don't find it?
hear what's going on.
if
Hear
it
what's
on-
going on. You hear Mr. Mackenzie describe it the first time? Where must
That's the long way.
No boy, video. No.
Hello?
You could see one thing.
No, I see that's the long way I do it now, but you're way shorter. I don't realize that.
Yeah, but listen, it's not all right and wrong when it comes to the answer. Is what way somebody could understand. And that's the point that us bring across. You do it in a way that you could understand. If you remember that way, right, you get the answer. If you remember the next way, the important thing, you get the correct answer. Right? So I'm sorry my camera ain't working, otherwise I'd use my blackboard. I have a blackboard and I write it on the blackboard and show you the steps. But my camera doesn't work.
Take away 1.
Everybody with me?
Yes, sir.
So Mr. Kado, the final answer is what? Minus 5 1/4?
Oh, you can't get minus Andreas. Andreas, listen me.
Yeah, but
Listen me. Listen me well, Andreas. Listen this one. If you have 6 1/4 inches, right, and you minus 1 1/2, you can't get a minus. So anytime somebody tell me to get a minus answer, I know it all off the bat. You will never get a minus.
well then.
Never measure and take. Andreas,
Yeah, but baby.
hold on. Listen. Don't talk yet. Just say yes. Right. if you have a measuring tape close by, right? And some students, right? Somebody turn off the microphone there. Again, some feedback. Right. Right? They say, sir, but this thing easy. They pull out the measuring tape. And if I give them that sum like that, 6 1/4, they pull it out the measuring tape 6 1/4 inches. Right? And then after the minusing, they're stepping back 1.5 inches on the measuring tape. And they get in the answer without even writing down any sum. But what I try to show them, I say, yes, that is good. But if you get a big measurement now, if you're in a place and you don't have a measuring tape on you, how you working it out?
In mils.
Somebody saying mils, right? But this is just to stimulate your brain for you to think in line of the calculation and stuff, right? I know this one might be, I know some people that tell me a negative answer. I put it knowing that.
Yes, Sakaro, what is the answer for that?
The answer is 4 3/4. Now listen, man. Now we describe two methods of working it out. The first method is how what Mr. McKenzie was saying. Now listen it good. It's going to be 6 multiplied by 4, the whole number, multiplied by the denominator. Right? 6 multiplied by 4, you get 24. And then you add that one on top. So you're ending up here with 25 over 4. Right? You're turning everything into a proper fraction then. And then after, what you're doing now, you're minusing. And you're going on the next side. You're saying 1 multiplied by 2 is 2 plus 1 is 3. So again, 3 over 2.
Yeah, but you're subtracting.
Right? But what they did, they turned the 3 over 2 into quarters. And how you do that, you multiply the top and the bottom by 2. Because if you want the bottom to turn a quarter, it will be 2 multiplied by 2. It will be 4. So when you multiply top and the bottom by 2, you now have 25 over 4 minus 6 over 4. Right? Bottom line behind it. Ending up with 25 minus 6 is how much? 19, right? Over 4. Right? And if you take 19 and you divide it by 4, you're getting 4, and the remainder is 3 over 4.
Right.
So you get 4 3/4.
Right.
Do you understand that way?
Right, Mr. Kado, which means, right? Now we're saying this correct, which means, so whenever is a fraction like that, you're moving from, so it's a subtraction, so you're moving from subtraction into multiplication, right, in order to get the answer. Because that is way doing it. 6 by 4, 24, 125, that is multiplication to get the answer.
You're turning it into an improper fraction.
Right. True multiplication.
Fraction.
Yeah, true multiplication.
Right? You turn it into improper fraction. Now that is one way. Right? That is one way. How I prefer to work it out is putting the 6 1/4, and if all you follow me, all you can write it down. 6 1/4, and we go minus the 1 1/2. But here what we're doing, a quarter is less than a half, right?
Yeah.
Because if you look at it, don't look at the whole number yet, look at the fraction itself. When you look at the fraction, a quarter is less than a half. So what we're doing in this case, it just come like if you're saying my mother gave me $6.25
Oh,
to go to the grocery. And I spent $1.50.
That door
That is what it have, you know. That is the exact sums, you know.
1, 2, 3.
You have $6.25. You're going to the grocery because quarter is 0.25, right? Half is 0.50. So you really have $6.25, and you go to the shop or the parlor, but you spend $1.50. All right with me? Dollars and cents.
Yeah, yeah.
Right? Well, people don't understand when you talk money better, you know. Right? So here we are doing in this case. You say, hey, you see, 25 cents is less than 50 cents. So for me to add a minus that good, I had to borrow 1 from the 6. And if I borrow 1 from the 6, 5 will remain. But I want why borrow from the 6, right? That is really $1 I'm going to put with my 25 cents. Now listen, we're talking dollars and cents. If you borrow $1 have 4.25 cents in it, right? Only with me? So $1 is 4 quarters. So you come like, you see that 25 cents you have? Or that quarter, you add into that 4 quarters. Right? So if you have 1 quarter and you add 4 quarters to that, you're ending up with 5 quarters. Right? Only with me? If you have 1.25 cents and your neighbor gave you 4.25 cents, and you have 5.25 cents, so you have 5 quarters. I wonder if I get in truth earlier. Right? So you now have 5 and 5 quarters minus 1.5. So you can work from there. Because we have more quarters than what on the minus side. I lost all you. What's going on? Mackenzie?
But sir,
I follow it.
But sir,
Yeah?
I find it simpler to just turn it to improper fraction, but I understand what you're saying.
That is what I say. Now I'm showing you the 2 ways. I'm telling you the 2 ways. But you select which way you prefer that.
Yeah.
Right? So I carry on on a trip. And I pass 2 ways with you. We pass a long way, and then we pass through a track, and we take half an hour to reach. When we pass through the track, we come through the 10 minutes. And you will prefer go through the 10 minutes track. Right? But what I'm saying, right? When you're looking at fraction, right? Besides turning it into a proper fraction, you could borrow. And you just have to think about it as dollars and cents. Now, for some of you all who was in the class before, you know, in this case, I might have just put 6 and a quarter and a pound minus, and underneath it, and I put 1.5. So I thinking about it as money one time. Now, some people don't learn quicker way, right? Just put 6 and a quarter, and under that, it comes like if you're writing dollars and cents. Instead of you put 6.25, just write 6 and a quarter, and underneath that, put minus 1.5. We're not doing this line technique, right? So if you're with me, Mackenzie, if you're with me, just mark 6 and a quarter, and under that 6 and a quarter, put minus 1.5. Like if you're going to calculate money, right? That's the next way.
You're lining up the 2 whole number and lining up the 2 fraction on one another.
Yes, you're doing that.
Right. I can follow in here.
Right. So when you do that now, you say, hey, quarter less than a half. So you're borrowing from the 6, right? When you borrow from the 6 that turns into 5, you're adding 4 over 4. So you're adding 4 quarters. So you're going to end up with 5 over 4. Right? And you see that half? To make it simple, turn the half to quarter. So if you turn half to quarter, you're going to be minusing 2 over 4. Right? We're not minusing the denominator. That remaining the same. That is 4. 5 minus 2 is 3. And 5 minus 1 is 4. And they get to 4 3/4. You see it, Mackenzie?
Yeah.
Right. So it has different ways. That's 3 different ways. 3 different ways you can line up the sum to get back to your 4 3/4. Right? But as I said, this is more or less revision. This is just to stimulate your brain. So let me move on.
Different calculus again.
Right?
It's breaking laws.
Multiplication of fraction. You just talk about it, but we ain't doing no example in this, right? So what I'm saying here now, if you're multiplying a fraction, right? When multiplying 2 or more fractions, first multiply the top numbers, right? Then multiply the bottom numbers together, right? Mixed numbers must always be converted to an improper fraction. Mixed numbers must always be converted to an improper fraction. So what I'm saying, like how we had the mixed number just now, right? The 6 1/4. Remember, we turn it into an improper fraction. So it could be like 25 over 4, right? So that's what I'm saying. If you're multiplying and you have a mixed number, turn it into an improper fraction, then multiply it out. So for this example here, we have 5 over 8. Multiplied by 3 over 7, right? And you could write it as this. The example is saying here, 5 multiplied by 3 is 15. 8 multiplied by 7 is 56. And that's the answer. You can't break down this. So your answer remains the same. Right? Everybody understand that?
Yes, sir.
Yeah.
But what they say here in the example, say for instance, so let me just do one. Let me just follow the example and just do one. Right?
I don't want to do none.
You ain't want to do none?
Let you do it.
Right? Let me say, remember they talk about if you have an improper fraction. So let me just say we have 2 1/4. Right? Multiplying that by 3/4. Right? All you want to work it out?
Wait,
just follow the step. So before you multiply it, right? 2 1/4 multiplied by 3/4. But the step say if you have a mixed number, always convert it into an improper fraction. So let me convert it into an improper fraction, and then after all, you will give me the answer. So we taking the 2 1/4, we converted it into an improper fraction. We're saying 2 multiplied by 4 is 8 plus 1 is 9. So we get 9 over 4. Multiplied by 3 over 4. And work it out from there.
Yeah, yoga. 1 and 11.
Wait. Give them a chance.
That's it.
That is heat. That's my title. Then walk the truth on the ground.
Is that I don't know.
Yeah.
I could say it.
Who is that? Yeah, go ahead.
Right. It'll be 1 and 11, 16, or 27, or 16.
So all agree with she?
I don't. Waiters?
Yeah.
Yeah, where's the answer then?
Yeah. Of course.
Is it what 1 and 11, 16?
Yeah.
Yeah, that's it. Satisfied?
All good? So all understand what we're talking about. Right? All get it. So we're moving on. Right? Well, the division. The thing about the division, they say when dividing fraction, invert the fraction you are dividing by. So what do you mean invert? You see they say 3 over 5 divided by 2 over 7. Right? So this 3 over 5 really divided by this 2 over 7. So we inverting the one we dividing by. So we leaving the 2 over the 5 the same way, and when they say invert, you're just flipping it in. When you're dividing by, you're flipping it. So you put 7 over 2 and you multiply it out. And you get
You could repeat?
Right. So the steps is when you're dividing a fraction, invert the fraction you are dividing by, then multiply the fraction. So the example was showing you 3 over 5 is divided by 2 over 7. The step is dividing by, we inverting it. When we mean inverted, we just mean we flipping it. So the 3 over 5 remain the same, right? The division turn into multiplication, and because we change the function, we invert or we flip this. So we put 7 over 2, and we multiply it out. 7 3s are 21. 5 multiplied by 2 is 10, right? If you want to break it down further, you're getting 2 and 1 over 10.
Yeah, 2 and 1, 10 or 21 or 10.
Right. So everybody agree with that? Only 5 is too much.
Yeah.
But we have some other things to cover, so we're moving on quickly. Right? Decimals. So anytime you start to think about decimal, or we start to talk about decimal, we have to think about the metric system. Now this is a basic rundown on decimal here. So what they're saying about decimal, they say decimal system is an extension of our ordinary number system. When we write the number 666, we mean 600 plus 60 plus 6. Reading from left to right, right? Each figure is 10 times the value, right? Decimals then are fractals which have 10, 100, 1,000, and so on, right? So decimal are factors which have 10, 100, 1,000, so on. Right? You see an idea?